Chapter number 5 start with the subprograms and package. In this chapter, we are going to learn how to make a subprograms, how to make a functions, how to make a procedure, and how to declare a package and write a package body. Subprogram consists of basically two types: procedure and function. Procedure can return more than one arguments and the function can return just one argument. That is the main difference between the procedure and function. Procedure can returns more than one arguments, whereas the function returns only one arguments. Now look at the example of the function. Function described as we have an example for the function library. Use of library IEEE, use of IEEE dot standard logic 1164 dot all, package by the name of num type is type by the name of log 8 is an array of 0 to 7, that is 8 bit of standard logic. End of the package by the name of num type. Again, use the work dot num type all. Entity, start with the keyword entity, name the entity with convert, is port input I1 of type of log8, which we already defined in the package. Log8 is nothing but the array of 0 to 7, that is 8 bit. Output 1 is the output integer, end of entity convert. Architecture named by behave. Architecture, start with the keyword architecture, name the architecture with the word behave of entity convert is. Now here we are writing the function. We will give the name to the function as a vector to int, and s is the argument of the type of log8. Log8 is nothing but we have defined in the package is array of 0 to 7 of standard logic. Return return value is nothing but what we will return from the function, what we will get from the function. Here we write return integer type is variable by the name of result. It's an integer type and have assigned initial value as 0. Begin for I from 0 to 7 loop result into 2. If Si is 1, then result plus 1, end of if loop, end of loop of 4, and return, end of return result. This is the result which we are sending from the function. That is the return value. Okay, the function begin with the word begin, and we write the function statement. Okay, and we ended function with end vector to int. This is total the function definition. Function declaration comes between the line number 5 and 6. Function begin with the keyword begin, ends with the end and the name of function, that is vector to int. Now the architecture begin. Okay, what architecture begin? Architecture says begin output 1, that is output 1 signal is assigned the value of vector into I1. Already we have said integer whatever we are sending inside the I in vector to int function is a log type. We have said that the argument which is sending to this function is of the log 8 type. That means 0 to 7, 8 bits. I1 we define, therefore in the port of the entity is of the log 8 type. This is the example of a function. Okay. Now function lines are in between. You can see 4, 5, 6, 7, 8, 9, 10, 11. After 11 the functions ended. And 12 line is the line for the architecture behave. It was not included into the function. End of the architecture named behave and the programs ended. This is an example of the function. We will look for the next example for procedure. Now, in procedure, in early section we already discussed about the function. We have seen the example of function. Now procedure have a basically same syntax and rule as a function. Only main difference between the procedure and function that it returns more value, whereas function returns only a single value. Okay, so procedure can have any number of inputs and outputs and input output parameters, not fixed that you have to return a single value, whereas function can have only a single value in a return. Okay, a typical example of procedure is shown in the following example. Use library IEEE, use IEEE dot std logic 1164 all procedure having a name of vector to int, again having a port z in the standard logic vector, that means it will be an array. Okay, as described into the standard logic of the IEEE. X flag output boolean type, q is inout integer. Procedure begin with the word begin. Now this q is equal to assign the value. This is a variable. Assign the value equal to 0. X flag assign the value of false. For loop start for I in Z range. Okay. Loop q into 2. If Z is 1, then q plus 1. Else if Z is not equal to 0. This is the misprint in the book. It should be not equal to 0. There is only two conditions. Either Z is equal to 1 or either Z is not equal to 0. F is returned by mistake or printed by mistake in the book. Then X flag has assigned the value true. End of if loop, end of for loop, end of the procedure. Having a name vector to int. Here is the description. If the F has a, if X value is 1, then it is added to the result, and if value is 0, then no addition is done. That means that was the misprint. Okay. Again we will see further. The side effect of procedure. A procedure have an interesting problem that is not shared by the other by their function counterpart. Matlab that interesting problem is not with the function, but there is a problem with the procedure. In a procedure, you can change the value of a signal which is not defined into the procedure but defined into the architecture. For instance, a signal of architecture can be assigned a value within the procedure without that the signal being an argument passed into the procedure. For instance, if there are two signals are not declared in an argument list of procedure but are assigned from within a procedure is called from a current procedure, then any assignment of these signal are the side effect. That means you can assign the value of signal inside the procedure without passing that signal value from the architecture to the procedure. Next topic we are going to cover is the package. Okay, two main thing we are going to learn in the package is package declaration and package body. Now, package declaration should declare some part of the program like subprogram declaration, subtype declaration, constant, defer constant declaration, signal declaration created for the global signals, file declaration, component declarations, attribute specification, and use of clause. These declaration and these points should be covered into the package declaration. Now, what is the deferred constant? A defer constant is also a constant. We have already learned the constant concept beforehand in chapter number 3. Chapter number 4. The defer constant is also our constants that have their name and type declared in the package declaration. That means the constant is defined through the package declaration, then it is called as a deferred constant. For example, package tpack is constant timing mode. Constant name is timing mode. It's a type of T mode. Now T mode is already defined in above, that it's a timing mode. It defined as a T type mode. Okay. End of the tpack. This is the deferred types of constant. Now subprogram declaration. You can define or declare a subprogram inside the package declaration. Now package named by cluster pack is type 9 will is, you can see it is a 9 arguments. Type T cluster is an array of 15 of 9 will. That means total 16 row having every row have 9 elements, 9 arguments. Okay. Type T cluster vector is an array of natural range. We have not defined any range over here of the T cluster. Function, okay, this is the subprogram. Function by the name of resolve cluster as is the argument of the type T club vex. Now, T club vex is defined above, is array. Okay. Return type T cluster type, subtype TWIC is resolved cluster type, constant undriven T vehicles. End of the class pack. That is the package. We will use this package for the next package body. Now, package body main purpose of package body is to define the value of defer constant specific subprogram bodies from any other subprogram declaration. However, package body can also contain the following declaration: subprogram declaration, subprogram body, type and subtype of declaration, constant declaration, file declaration, and clauses.